Hello students, today we are going to discuss the topic that is phenol. In the last class we discussed the preparation and properties of alcohol. We know phenol is an aromatic alcohol. The functional group is remains same, OH group, but only difference is in alcohol OH is attached to R, OH is attached to R. That means R is here, that aliphatic chain, open chain compound. But in phenol, OH group is attached to aromatic ring, that is benzene ring. That's why it is called phenol. The group is phenyl, and phenol also written as PH, short form PH, OH. It is also written as that AROH. It is also written as C6H5OH. So three ways you can write the phenol. Some book written also like this, that is 5OH. 5, that is phenyl symbol. So these are different that representation of phenol. It is an aromatic alcohol. So phenol and phenol derivative like this. We will discuss later the preparation of that aromatic derivative of phenolic derivative. We will discuss later. So first discuss the preparation of phenol. What are the preparation methods? Phenol can be prepared. First, already you know, we have discussed in haloarine and haloalkane chapter that if you take haloarine when it reacts with alkali, then at high temperature 633 K and 300 atm pressure, high temperature, high pressure when given to haloarine and sodium hydroxide, it produces phenol, and this process is called Dawes process. It is also called Dawes process. Dawes process. Better you write this all nomenclature in different indication and give your class notes so that you can read later. It will be easy. Then from haloarine you can prepare that is phenol. Phenol can be prepared from that benzene. You can prepare benzene. If you take benzene, benzene when reacts with concentrated sulfuric acid undergoes sulfonation reaction. Already know aromatic with electrophilic substitution produce SO3H. When SO3H will be treated with NaOH, then produce and salt, that SO3Na. When it undergo hydrolysis, acidic medium hydrolysis, the result is phenol. So from benzene, sulfuric acid can be converted to phenol by action of the sodium hydroxide, then followed by acid hydrolysis. So in this way also you can prepare phenol. Third method of preparation from cumin. If you take cumin, this is called cumin. Cumin, or it is also called as that 2-phenyl propane, 2-phenyl propane, or it is called isopropyl benzene. Isopropyl benzene. This common name is cumene. When cumene undergo oxidation, radial oxidation, when it reacts with oxygen, it easily oxidizes because very active hydrogen is present here at this position, that is tertiary nature, very active carbon, active hydrogen is there, so product will be that. This is called that peroxide, hydroperoxide derivative of cumene, peroxide. This is called peroxide, hydroperoxide derivative of cumene. When this undergo acid hydrolysis, it produces what? Phenol. Then acetone. This is acetone, this is phenol. So phenol can be prepared from cumene, phenol can be prepared from benzene, phenol can be prepared from chlorobenzene, and it can be prepared another method from BDC. If you take BDC N2 plus Cl minus subforming BDC benzene diazonium chloride, when it undergo hydrolysis, warm water, then it produces phenol and nitrogen. And this reaction is very important. That phenol is produced, it will float on the surface of water, warm water, as a oily liquid, that is phenol, because phenol is not highly soluble in water. So this is the main important preparation of phenol, from chlorobenzene, from benzene, from cumene, and from BDC. Then what are the properties of phenol? If you discuss the properties, first you see phenol, water soluble but not highly soluble, less soluble, solubility is very low due to phenyl group, presence of phenyl group, but as it is soluble because due to formation of hydrogen bonding with water, so water soluble. Then that corrosive, it is also corrosive, corrosive to steam. It is acidic nature, mainly acidic nature, because you see why phenol is an acid. If you see the resonance structure of phenol, that in presence of water it will produce phenolate ion. Plus H2 plus, and this phenolate ion is stable by resonance. This is the phenolate ion which is stabilized by resonance. You can draw like this. That's why, as this is a conjugate base of phenol, that as it is stable, that's why phenol is given acid. It is an acidic nature. Because when it dissolves in water, when it mixes with water, it produces phenolate ion, because phenolate ion is what? Stable by resonance. But one question is, but it is a weak acid. Why is it weak acid? Because it maintains equilibrium between phenolate ion and phenol. That because the phenolate ion produced, it does not allow the loss of H plus ion completely from phenol. That's why it is maintaining equilibrium between the phenolate ion and phenol. That's why it is a weak acid. The reaction is reversible and slow process. That's why it is a weak acid, not a strong acid. As it is But when phenol will be kept in open air, if you keep phenol when it is exposed to air, then phenol will be oxidized to in presence of oxygen and light. It converts to benzoquinol. It gets oxidized. This is a dark color substance produced. That is, phenol generally quite solid, colorless liquid, but when it will be exposed to light and oxygen, then it will be oxidized to benzo. This is called benzo, that is quinone. That is quinone or benzoquinone, it is called. That is dark color. That's why after long days, if after more days, you will see phenol change its color to dark, reddish dark color, due to the oxidation of phenol to benzoquinone. And phenol also, this phenol can be easily oxidized by KMnO4 or potassium dichromate. By potassium chromate, potassium dichromate can oxidize phenol to what? Same benzoquinone. This is your catalytic oxidation. This is aerial oxidation. Aerial oxidation, catalytic oxidation. Both will give benzoquinone. That is quinone. Dark substance will be produced. As phenol is acid, phenol reacts with. As it is an acid, it reacts with metals. It reacts with sodium metals, produce phenol, sodium salt of phenol, and hydrogen gas is produced. This is very important that phenol is an acid. It reacts with sodium metal, and it also reacts with base, producing salt. Phenol reacts with base, producing salt and water. This is a very common reaction, acidic nature of phenols. Then phenol, as it is acid, but phenol, this phenol cannot react with sodium bicarbonate. No reaction. This is very important. Although it is acidic character, it has acidic character, but it cannot react with sodium bicarbonate because phenol weak acid. It is a very weak acids. That's why it cannot produce carbon dioxide gas. That's why no reaction takes place between phenol and sodium. That is a very important distinction we can use. I can identify phenol. If you add sodium bicarbonate to phenol, there is no evaporation of CO2 gas. No CO2 gas is produced. That indicates the phenol. But all carboxylic acid when reacts with sodium bicarbonate produce carbon dioxide gas. This is the main difference between phenol and carboxylic acid. So phenol, acidic property of phenol. Then phenol can be, it shows electrophilic surface reaction, electrophilic substitution reaction, electrophilic substitution reaction of phenol. We can write here that already before that, just I will tell you phenol as we can draw in the middle also. As phenol, if you draw here, phenol has resonance. Due to resonance, electron density increasing at ortho position and para position. This is your ortho position, this is your para position. That's why for electrophilic substitution reaction, phenol gives ortho-para substituted product. For example, if you do nitration and sulfuric acid, then product is what? Ortho-para nitrophenol, NO2 plus this one. Ortho and para nitrophenol. Phenol same, but if you use this one fuming nitric acid, fuming concentrated nitric, fuming means gaseous nitric acid used, you will get what? Formation of both orthopara, both position will be substituted by nitro group, and this is trinitrophenol, that is called trinitrophenol. It is also called that picric acid. It is also called picric acid. Yellow mass is formed. Picric acid, trinitrophenol. So this is one important that is the identification test of phenol in presence of fuming nitric acid produce yellow mass of picric acid. Then this is nitration, sulfonation you can do also, sulfonation of benzene, sulfuric acid, same orthopara produce plus ortho product, para product plus ortho product. Then sulfonation, phenol also undergo what? Alkylation, CH3, Cl and aluminum chloride, that is your Friedel-Crafts alkylation, and the product is this is ortho plus para, ortho and para. This is called crescer. This is called orthocrescer. Crescer, formation of ortho para crescer. This is called alkylation. Acylation also possible. If you use CH3, CO, Cl in presence of aluminum chloride, you will get ortho para substituted phenol. This is very important. That is Friedel-Crafts, acylation, alkylation, sulfonation, nitration, then halogenation also possible. Halogenation is, suppose if you use bromine and carbon tetrachloride, if you use, product will be orthopara bromophenol plus para product. This is ortho product. Always ortho and para both. But this reaction, if you use which one? If you use bromine and water, the product will be both ortho para will be substituted by bromine. Tribromophenol form, it gives white color, white precipitate, white PPT. That is very important indication. Similarly, phenol can be identified by adding fuming nitric acid, yellow precipitate is formed. Phenol, when add bromine water, then gives white precipitate of tribromophenol. This is very important, that electrophilic substitution reaction of phenol at position ortho and para due to more electron density by resonance. This concept already know this one. Then other than this, what are the other electrophilic substitution reaction of phenol? Let us discuss. Okay, you complete this one, then I will erase it. You finish. Okay. Phenol reacts with zinc metal on heating, produce benzene. This is the reaction of OH group of which one? OH group of phenol. That CO group of phenol producing benzene and zinc oxide. In this reaction also, that a reduction, here phenol gets reduced to benzene. Then phenol, that is reacts with first step sodium hydroxide, second step carbon dioxide, and third step you can write hydrolysis. The product is that carboxy derivative of phenol. Carboxy derivative of phenol, this is called salicylic acid. Salicylic acid. This compound is called salicylic acid. This reaction is called Coles reaction. Coles reaction. Very important reaction of the chapter phenol. Phenol reacts with sodium hydroxide, then chloroform, sodium hydroxide and chloroform. Then product is salicylaldehyde, aldehyde derivative. This is called salicylaldehyde. Salicylaldehyde, and this compound, if you take sodium hydroxide and carbon tetrachloride, overall electrophilic substitution. This is electrophilic substitution. This is also electrophilic substitution, and product is salicylic acid. Salicylic acid is formed. This reaction is called Reimer-Tiemann reaction. The Reimer-Tiemann reaction. One important name reaction, that is Reimer-Tiemann reaction. RT reaction, short form is RT reaction. Coles reaction is very important. Two important name reaction of phenol, the chapter phenol. Coles reaction and Reimer-Tiemann reaction. So this is the important chemical properties of phenol. Phenol can be converted to its derivative. Then phenol can be ethylated when phenol reacts with acid derivative CH3 COCl without aluminum chloride or acid anhydride CH3CO2O. The product is that one ester derivative of phenol, acetylphenolate. This is called acetylphenolate. So we can tell this one or phenyl ethanoate. You can also, this is ester CH3 COOCH3, phenyl ethanoate or acetylphenolate. If it is acetyl derivative of phenol, you can tell acetylphenolate. So this compound is produced, which is that without taking aluminum chloride. If you take aluminum chloride, you will get substitution or orthogonal composition. That is called phenyl cup acylation. So direct acetyl chloride or acid anhydride if you use, then you will get that ester derivative of phenol. So this reaction is also very important. Then if you see acidic nature of phenols, already I have told you phenol is an acid because phenolate ion is more stable by resonance. But if you use the derivative, phenol, you tell that we know that electron withdrawing group, that is effect of electron withdrawing group and electron donating group. This thing we have to use. If phenol, then phenol derivative, suppose this one, that methyl derivative. If another one will take nitro derivative. Here it is a plus I effect, already know plus I effect expressed by methyl group. This is called plus I effect. Here it is a minus I effect. Already know this concept, plus I effect, minus I effect. So as plus I effect, suppose this is A, this is your B, this is your C. We will compare the acidic character of phenol. So phenol, then para, that is called paracrystal. This is called paranitrophenol. If you see minus I effect, generally acidic character increases. First one will be C greater than A greater than B. This is the order of acidic nature. But taking same crystal, suppose nitro, but you know if you take crystals derivative, crystals are ortho, para, meta. If you see the derivative of ortho, para, crystal, the order of acidic character will be, first one is your meta will be more acidic than ortho than para in this case, because meta position, if you write the structure, this remember, I can write all these three structure, it will be better. If you write here meta derivative, this is meta crystal, this is your ortho crystal, and this is your para crystal. Here what happens, meta position, it has no that only plus I effect is there, but no hyperconjugation. Hyperconjugation effect is very less at meta position. Hyperconjugation effect is more at ortho position and para position. That's why due to hyperconjugation, it increases electron density. That's why the loss of proton will be slow. That's why para and ortho both are less acidic than meta, because it has no hyperconjugation effect at meta position. So meta position is more acidic than ortho than para. But all these three are less acidic than phenol. Okay. Then if you nitro derivative, you see nitro derivative, that is nitrophenol, if you write nitrophenol derivative, you will think that nitrophenol derivative, you know that same nitro group generally increases acidic character, ortho, para, nitro. Most order generally para greater than ortho, greater than meta. Your para position is like this. This is para and this is ortho and this is your meta. Here acidic character in this way. Why? Because just nitro group is opposite to OH group, so the minus effect is more. That's why paranitrophenol is more acidic than ortho than para. This is the order of what? The acidic character of ortho. Why in case of ortho acidic character less? Because due to hydrogen bonding. Due to hydrogen bonding, OH group, NO2 group, due to intramolecular hydrogen bonding, acidic character is less compared to para. That's why para, then ortho, then meta. This is regarding the acidic character of phenol derivative, that is plus effect and minus effect. Then another thing is one important thing I will tell you, very important thing. More K value. This thing is very important. Keep it in mind. More K value means dissociation acid. More K value, more acidic nature, but more pK value less acidic nature. More K value, more acidic, but more pK value. pK means minus log K. Already you have read that more pK value, less acidic. That means if you compare pK value, suppose this is if you compare pK value of orthopara meta pressure. If meta is more acidic, so pK value order will be pK value order of meta orthopara pressure will be which is more acidic. Meta is more acidic, so pK value is less. So meta will be less than ortho than para. Regarding pK value, if K value is asked, K value will be M greater than or greater than para. Just opposite. Higher acidic character, higher K, but higher acidic character, lower pK. So in this also you can, sometimes question is asking that the relation between K value, comparison of K value, pK value instead of acidic character like this. So this is regarding what? The acidic nature of phenol. Okay. Phenol generally it is, suppose you discuss the derivative nature of that boiling point character and volatile nature. Suppose this is your that nitrophenol, orthonitrophenol, paranitrophenol and orthonitrophenol. If you see, this is also very important comparison. If you see the boiling point order is this one, BP, boiling point. Para greater than ortho because the intermolecular hydrogen bonding is stronger in case of meta, that is ortho. That's why orthonitrophenol has more boiling point than orthonitrophenol. Para has more boiling point than ortho. But this is volatile, more volatile nature. Which one? This one, ortho, because due to what? Intramolecular hydrogen bonding. As it has intramolecular hydrogen bond between OH group and NO2 group, so the attraction between the molecules will be less because of these two groups already bonded to each other. That's why interaction between the molecules will be less. That's why the generally orthonitrophenol is more volatile, easily evaporates because due to intra. Remember this thing, where molecule having intramolecular hydrogen bonding, then inter linkage will be less. That molecule interaction will be less because the group already attached in the molecule. It is already involved in intramolecular hydrogen bonding. So next further interaction will be less. That's why it is more volatile. This concept you have to remember. So this is very important regarding the nature of ortho paranitrophenol. And if you see that the difference between the distinction between that alcohol and phenol, if you compare, just one thing I want to tell you, that acidic character of that phenol and alcohol. If you see, alcohol will be less acidic than phenol because this conjugate base is RO minus after loss of hydrogen. Its conjugate base is that PHO minus, but PHO minus is stable. This is stable. by resonance, already discussed. Phenolate ion, if the conjugate base is more stable, then parent acid is more acidic. So phenolate ion is more stable than alkoxide ion. That's why phenol is more acidic than alcohol. And if you compare the three types of alcohol, acidic character, if you compare, this is your primary alcohol, this is your secondary alcohol, and this is your tertiary alcohol. If you compare the acidic character, then you see as the 3 plus I effect is there, here 2 plus I effect, here only 1 plus I effect. So this is plus I effect. As number of plus I effect is more, acidic character is less. So tertiary less than secondary, less than primary in acidic nature. Because the OH group, related to OH group interaction. When OH group will be considered the participation of OH group, that tertiary will be less reactive compared to secondary than primary. But when you compare the CO bond interaction, reactivity, tertiary greater than secondary, greater than primary, that is reactivity. Reactivity considering CO bond. When you consider CO bond interaction, then tertiary greater than secondary, greater than primary. But when you consider the OH bond interaction, then primary will be more active than secondary than tertiary, because due to plus effect. It cannot lose H plus easily, this one, because due to plus effect the electron density at oxygen atom will be more. So it attracts the releasing H plus, so that H plus cannot easily remove from O minus. That's why acidic character is less. So this is regarding the properties of phenol and some comparison with alcohol. So practice more about this chapter. Any doubt, you can interact with me. Okay, next class we'll discuss about the preparation and properties of ether. Okay, thank you all.